kind of cold. That's not what I'm looking for. Oh, damn it, I already have that installed. I don't know. What's the fucking temperature? Yeah. I'm kind of cold, ain't gonna lie. You know, I need. Damn. Nicotine. I'm kind of cold, nigga.
If you're not used to working with databases or exploiting them, there's probably some new terminology to get used to, so let's start with some basics on how databases are structured and how they work. What is a database? A database is a way of electronically storing collections of data in an organized manner. A database is controlled by a DBMS, which is an acronym for Database Management System. DBMSs fall into two camps, relational and non-relational. The focus of this room will be on relational databases. Some common ones you'll come across are MySQL, Microsoft SQL Server, Access, PostgreSQL, and SQLite. We'll explain the difference between relational and non-relational databases at the end of this task, but first, it's important to learn a few terms. Within a DBMS, you can have multiple databases, each containing its own set of related data. For example, you may have a database called shop. Within this database, you want to store information about products available to purchase, users who have signed up to your online shop, and information about the orders you've received. You'd store this information separately in the database using something called tables. The tables are identified with a unique name for each one. You can see this structure in the diagram below, but you can also see how a business might have other separate databases to store staff information or the accounts team.
I'm tired. I'm tired. What the fuck's calling me? No, nigga. Fuck, man. I'm studying. Way middle studying. I don't know what my cat's doing. Oh. Studying. You know. Oh.
SQL injection. Learn how to detect.
I'm talking about, yeah, that's right. SQL injections is like database servers.
What are tables? A table is made up of columns and rows. A useful way to imagine a table is like a grid with the columns going across the top from left to right containing the name of the cell and the rows going from top to bottom, with each one having the actual data.
I don't know why you're wet, girl. It's weird.
Columns. Each column, better referred to as a field, has a unique name per table. When creating a column, you also set the type of data it will contain, common ones being integers, numbers, strings, standard text, or dates. Some databases can contain much more complex data, such as geospatial, which contains location information. Setting the data type also ensures that incorrect information isn't stored, such as the string hello world being stored in a column meant for dates. If this happens, the database server will usually produce an error message. A column containing an integer can also have an auto-increment feature enabled. This gives each row of data a unique number that grows, increments, with each subsequent row. Doing so creates what is called a key field. A key field has to be unique for every row of data, which can be used to find that exact row in SQL queries. Rows or records contain individual lines of data. When you add data to the table, a new row/record is created. When you delete data, a row/record is removed. Relational vs non-relational databases. A relational database stores information in tables, and often, the tables share information between them. They use columns to specify and define the data being stored and rows actually to store the data. The tables will often contain a column that has a unique ID, primary key, which will then be used in other tables to reference it and cause a relationship between the tables, hence the name relational database. Non-relational.
I'm tired.
A relational database stores information in tables, and often, the tables share information between them. They use columns to specify and define the data being stored and rows actually to store the data. The tables will often contain a column that has a unique ID, primary key, which will then be used in other tables to reference it and cause a relationship between the tables, hence the name relational database. Non-relational databases, sometimes called NoSQL, on the other hand, are any sort of database that doesn't use tables, columns, and rows to store the data. A specific database layout doesn't need to be constructed so each row of data can contain different information, giving more flexibility over a relational database. Some popular databases of this type are MongoDB, Cassandra and Elasticsearch. Now that you've learned what a database is, let's learn how we can actually talk to it using SQL.
Wait, what is it? Rows? What am I thinking? What is it? Tables. No, I didn't get anything in the chest last time. Fuck is this?
SQL, Structured Query Language, is a feature-rich language used for querying databases. These SQL queries are better referred to as statements. The simplest of the commands which we'll cover in this task is used to retrieve, select, update, insert, and delete data. Although somewhat similar, some database servers have their own syntax and slight changes to how things work. All of these examples are based on a MySQL database. After learning the lessons, you'll easily be able to search for alternative syntax online for the different servers. It's worth noting that SQL syntax is not case sensitive. Select. The first query type we'll learn is the select query used to retrieve data from the database. The first word select tells the database we want to retrieve some data. The asterisk tells the database we want to receive back all columns from the table. For example, the table may contain 3 columns: ID, username, and password. From users tells the database we want to retrieve the data from the table named users. Finally, the semicolon at the end tells the database that this is the end of the query. The next query is similar to the above, but this time, instead of using the asterisk to return all columns in the database table, we are just requesting the username and password field. Yeah. Select username password from users. The following query, like the first, returns all the columns by using the asterisk selector, and then the limit 1 clause forces the database to return only one row of data. Changing the query to limit 1,1 forces the query to skip the first result, and then limit 2,1 skips the first 2 results, and so on. You need to remember the first number tells the database how many results you wish to skip, and the second number tells the database how many rows to return. Select asterisk from users limit 1.
Oh. Never knew that. Limit 2, 1, that skips first and then gives you that. Why would you want to know how to do that, though? Select all from users where username equals admin. Tired. It means not admin. Or something that has an A in it would be admin.
Union. The union statement combines the results of 2 or more select statements to retrieve data from either single or multiple tables. The rules to this query are that the union statement must retrieve the same number of columns in each select statement, the columns have to be of a similar data type, and the column order has to be the same. This might sound not very clear, so let's use the following analogy. Say a company wants to create a list of addresses for all customers and suppliers to post a new catalog. We have one table called customers with the following contents.
So union select means to put them together. So they have to have the same number. So why would you use it?
Insert. The insert statement tells the database we wish to insert a new row of data into the table. Into users tells the database which table we wish to insert the data into. Username password provides the columns we are providing data for, and then values. Bob password provides the data for the previously specified columns. Insert into users, username password values, Bob, password 123. Update. The update statement tells the database we wish to update one or more rows of data within a table. You specify the table you wish to update using update %table name %set and then select the field or fields you wish to update as a comma separated list such as username equals root password equals pass123. Then finally, similar to the select statement, you can specify exactly which rows to update using the where clause such as where username equals admin. Update users set username equals root password equals pass123 where username equals admin. Delete. The delete statement tells the database we wish to delete one or more rows of data. Apart from missing the columns you wish to return, the format of this query is very similar to the select. You can specify precisely which data to delete using the where clause and the number of rows to be deleted using the limit clause. Delete from users where username equals Martin.
Oh, I'm tired. I'm tired, man. I'm on the last one. Select, that's right. Union.
What is SQL injection? The point wherein a web application using SQL can turn into SQL injection is when user-provided data gets included in the SQL query. What does it look like? Take the following scenario where you've come across an online blog, and each blog entry has a unique ID number. The blog entries may be either set to public or private, depending on whether they're ready for public release. The URL for each blog
Yeah, you know what I mean, boy. See what my son's doing. He might be sleeping. Whole ass nigga.
entry may look something like this: HTTP URL. From the URL above, you can see that the blog entry selected comes from the ID parameter in the query string. The web application needs to retrieve the article from the database and may use an SQL statement that looks something like the following: select asterisk from blog where ID equals 1 and private equals 0 limit 1. From what you've learned in the previous task, you should be able to work out that the SQL statement above is looking in the blog table for an article with the ID number of 1 and the private column set to 0, which means it's able to be viewed by the public and limits the results to only one match. As was mentioned at the start of this task, SQL injection is introduced when user input is introduced into the database query. In this instance, the ID parameter from the query string is used directly in the SQL query. Let's pretend article ID 2 is still locked as private, so it cannot. From what you've learned in the previous task, you should be able to work out that the SQL statement above is looking in the blog table for an article with the ID number of 1 and the private column set to 0, which means it's able to be viewed by the public and limits the results to only one match. As was mentioned at the start of this task, SQL injection is introduced when user input is introduced into the database query. In this instance, the ID parameter from the query string is used directly in the SQL query. Let's pretend article ID 2 is still locked as private, so it cannot be viewed on the website. We could now instead call the URL HTTP URL, which would then, in turn, produce
I'm lost on that.
The semicolon in the URL signifies the end of the SQL statement, and the two dashes cause everything afterwards to be treated as a comment. By doing this, you're just, in fact, running the query. Select asterisk from blog where ID.
I'm not preparing. I just do IT. I'm not really preparing anything in cybersecurity. IT these days, pretty much, it's a blended role anyway. So if you do IT, you're pretty much doing all of it anyways. I don't think there's even cybersecurity jobs out there anymore. If you find one, it's probably in a major city or online. I'm just learning right now. I'm just having fun, just learning. Not really having fun. I'm tired. I'm really tired. I work all day. But so far, right now I'm doing the fun shit now. This is the fun shit. I did all the defensive shit. I'm tired of that. Why is it acting like it's slow? I'm acting like my internet's slow or some shit. 2.5 gig internet. I know it ain't my computer. So we got that done. Did the blue team and shit. And that was really boring. So now I'm just doing some red team and shit. It's just like a game. So I'm not really preparing for anything. I'm just tired. I'm on day 246. So it's kind of just like a game for me. I don't think if I can get a job from it, it'd be cool, but I doubt it. When you're in IT these days, it's all blended.
Select asterisk from blog where ID equals 2,
right,
dash which will...
Hang on, so the semicolon... I don't understand where the private comes from. So they're talking about that blog, that URL somehow is pretty much... There's no way it's sending... I don't understand where the private's coming from. So it's trying to say when a website does that with its parameters, it's pretty much asking the database to select all from the blog where the ID is 1. But where does the private come from? And why is it limit 1? Well, I guess it has to limit 1. It's only one URL page. Yeah, I'll do Hack the Box later. I don't think I'm smart enough for Hack the Box, man. That shit's hard. I have trouble on some of this sometimes. So I don't know enough about networking, I feel like. But it does look like it's about to get fun though. Because I got I love messing with. I got Wireshark, and then I got Burp Suite, Network Miner. Burp Suite I've been having fun with Wireshark and Burp Suite lately. And I guess what's next, which I'm kind of excited for. This is the web penetration shit. It's all right, I guess, but I'm ready for the Burp Suite, and then I can learn more about Nmap, which I already know some basic port scans, but it'd be cool to learn some more. Nmap is pretty powerful too. I like fucking with Nmap and Burp Suite, so I'm kind of excited to learn more about that. I wish it taught more about Metasploit, because I already did all Metasploit shit, and I still don't really know enough about Metasploit. But this would be fun because I like to attack my network and see how strong it really is. So it's just for me to learn. All right, what's it saying? Select all from blog where ID equals 2. So could that really be a URL? Or how would you know if it's? I don't understand. Anyways, I'm tired.
Which will return the article with an ID of 2 whether it is set to public or not. This was just one example of an SQL injection vulnerability of a type called in-band SQL injection. There are 3 types in total: in-band, blind, and out-of-band, which we'll discuss over the following tasks.
So this was an in-band SQL injection. But how would you know it's vulnerable to a SQL injection? Just from the parameters of that website. That's what I don't understand. Damn. I'm too tired. I just want to get this one lesson done. I'm kind of tired. I'm not reading all that shit.
In-band SQL injection. In-band SQL injection is the easiest type to detect and exploit. In-band just refers to the same.
How to determine if a website is vulnerable to a I'm not reading that. I'm not reading all that.
To determine if a website is vulnerable to in-band SQL injection, you can perform manual tests using techniques like error-based and union-based attacks, or use automated vulnerability scanning tools. In-band SQL injection is a type of attack where the same communication channel is used to inject malicious code and receive the results. Manual testing techniques. Step 1. Identify potential injection points. In-band SQL injection vulnerabilities can exist anywhere a website uses user-supplied data to construct a database query. Look for areas that accept input, such as search bars, login forms, contact forms, URL parameters.
Okay.
Example ID equals 123, cookies and HTTP headers. Step 2. Test for error-based SQL injection. Error-based attacks are a direct way to confirm a vulnerability because the application displays database-generated errors to the user. Introduce a special character, append a single quote, to a parameter. For example, if a URL is example.com/products ID equals $123, change it to example.com/products ID equals 123. Look for error messages. A vulnerable application may return a detailed database error message, such as a SQL syntax error. This shows that the web application processed your input directly into a SQL query.
That's fucking cool. Alright.
Step 3. Test with Boolean logic. This technique uses a conditional statement to observe differences in the application's response. Test a true condition. Append a universally true statement like or 1 equals 1 to an input field or URL parameter. The is a comment, which often nullifies the rest of the original query.
Why is that needed?
Test a false condition. Append a universally false statement like or 1 equals 2 dash. Compare results. A vulnerable site will behave differently for the true and false conditions. For example, a search that normally returns one result may display all available results when or 1 equals 1 is used.
Huh. You have to use a semicolon. What's the semicolon mean in this? What is? What is the damn? I wish ChatGPT. Here, this is. I don't feel like having to explain it to ChatGPT. Damn it. Ugh. What does the single quote in this mean? What does it tell the database? Is the usual string delimiter in SQL. It tells the database start or end a string literal. If it's misplaced or left unclosed, the DB sees a malformed SQL and returns an error. And that same behavior is what attackers try to abuse in SQL injection. So the single quote is a string delimiter. What is a string delimiter? What is a string delimiter? A string delimiter is a character or a sequence of characters that marks the beginning and end of a string literal. This allows the database to distinguish between the actual string value and other. Okay. Damn. Really went off the walls on that one. Alright.
Error-based SQL injection. This type of SQL injection is the most useful for easily obtaining information about the database structure, as error messages from the database are printed directly to the browser screen. This can often be used to enumerate a whole database. Union-based SQL injection. This type of injection utilizes the SQL union operator alongside a select statement to return additional results to the page. This method is the most common way of extracting large amounts of data via an SQL injection vulnerability. Practical: click the green Start Machine button to use the SQL injection example practice lab. Each level contains a mock browser and also SQL query and error boxes to assist in getting your query/payload correct.
Okay.
You may need to refresh this web page once the machine starts if you get a 502 bad gateway error. Level 1 of the practice lab contains a mock browser and website featuring a blog with different articles, which can be accessed by changing the ID number in the query string. The key to discovering error-based SQL injection is to break the code SQL query by trying certain characters until an error message is produced. These are most commonly single apostrophes, or a quotation mark. Try typing an apostrophe after.
Hang on, Toothless. I know you just passed out on me already, but I gotta get me another water. Look at that. Look at her. Hang on, baby. Alright, Toothless. Okay, Toothless. Sorry, baby.
The key to discovering error-based SQL injection is to break the code SQL query by trying certain characters until an error message is produced. These are most commonly single apostrophes, or a quotation mark. Try typing an apostrophe after the ID equals 1 and press enter. And you'll see this returns an SQL error informing you of an error in your syntax. The fact that you've received this error message confirms the existence of an SQL injection vulnerability.
Okay.
We can now exploit this vulnerability and use the error messages to learn more about the database structure. The first thing we need to do is return data to the browser without displaying an error message. Firstly, we'll try the union operator so we can receive an extra result if we choose it. Try setting the mock browser's ID parameter to
How the fuck do I do that? I forgot how to do that. Hmm. How do I do a union operator? I'm already lost. I'm fucking lost. I'm already lost. Oops, someone got banned. Let's see who it was. One union. How do I do that? Fuck. I'm too tired. I'm fucking. I don't know, man. SQL injection. I don't need the answers. I want to walk through. Oh, literally just typing that? You're lying. You're lying. One union select one.
Success, the error message has gone, and the article is being displayed, but now we want to display our data instead of the article. The article is displayed because it takes the first returned result somewhere in the website's code and shows that. To get around that, we need the first query to produce no results. This can simply be done by changing the article ID from 1 to 0.
Okay. Where ID equals.
You'll now see the article is just made up of the result from the union select, returning the column values 1, 2, and 3. We can start using these returned values to retrieve more useful information. First, we'll get the database name that we have access to.
There's no article 0, right? Exactly. So that's the point of doing that, because we want no results. Okay, so we want no results in order to show our results. If it's okay.
You'll now see where the number 3 was previously displayed. It now shows the name of the database, which is SQL_1. Our next query will gather a list of tables that are in this database.
Jesus. Okay. So that. And select 1, 2, group concat table name from information schema tables where table schema equals what? How would I just know that? Article staff users. So I can change it from article to staff users. Let's save all this first. Staff underscore users. Really? They ain't got no users, really?
There are a couple of new things to learn in this query. Firstly, the method group underscore concat gets the specified column, in our case, table underscore name, from multiple returned rows and puts it into one string separated by commas.
Oh.
The next thing is the information underscore schema database. Every user of the database has access to this, and it contains information about all the
What is the function SQL?
databases and tables the user has access to. In this particular query, we're interested in listing all the tables in the SQL underscore 1 database, which is article and staff underscore users. As the first level aims to discover Martin's password, the staff underscore users table is what interests us.
Yeah.
We can utilize the information underscore schema database again to find the structure of this table using the below query.
Okay. ID, password, username. That's crazy. Just plain text.
This is similar to the previous SQL query. However, the information we want to retrieve has changed from table underscore name to column underscore name. This is similar to the previous SQL query. However, the information we want to retrieve has changed from table underscore name to column underscore name. The table we are querying in the information underscore schema database has changed from tables to columns, and we're searching for any rows where the table underscore name column has a value of staff underscore users. The query results provide 3 columns for the staff underscore users table: ID, password, and username. We can use the username and password columns for our following query to retrieve the user's information.
Select 1, 2. What? I don't understand how to read that. this out. Jesus Christ, it really does tell you every goddamn thing about it. This is a placeholder value for first.
Step-by-step explanation. 0. This is a placeholder value for the first part of a query that the attacker is trying to union with. Example, if the original query was something like select ID, name, email from users where ID equals X, the attacker replaces X with the injected code. Union select union in SQL combines the results of two select queries into a single result set. Attackers use this to trick the database into returning extra data, like passwords, from another table. 1, 2, group_concat, username, password separator BR, this is the list of columns being selected. 1 and 2 are just dummy values to match the number of columns expected by the original query. Group_concat, username, password separator BR, combines all rows from the table into one text string. Example output, admin 1234 BR John ABCD BR Susan Qwerty. The BR HTML tag makes each user/password pair show up on a new line if displayed on a web page. From staff_users, the data is being pulled from the table named staff_users, likely an administrative. Again, we use the group_concat method to return all of the rows into one string and make it easier to read. We've also added, to split the username and password from each other. Instead of being separated by a comma, we've chosen the HTML BR tag that forces each result to be on a separate line to make for easier reading. You should now have access to Martin's password to enter and move to the next level.
So that splits it, okay.
Blind SQL. Unlike in-band SQL injection, where we can see the results of our attack directly on the screen, blind SQL is when we get little to no feedback to confirm whether our injected queries were, in fact, successful or not. This is because the error messages have been disabled, but the injection still works regardless. It might surprise you that all we need is that little bit of feedback to successfully enumerate a whole database. Authentication bypass. One of the most straightforward blind SQL injection techniques is when bypassing authentication methods such as login forms. In this instance, we aren't that interested in retrieving data from the database, we just want to get past the login. Login forms that are connected to a database of users are often developed in such a way that the web application isn't interested in the content of the username and password but more in whether the two make a matching pair in the users table. In basic terms, the web application is asking the database, do you have a user with the username Bob and the password Bob123? The database replies with either yes or no, true/false, and, depending on that answer, dictates whether the web application lets you proceed or not. Taking the above information into account, it's unnecessary to enumerate a valid username/password pair. We just need to create a database query that replies with a yes/true.
want to see what it did here. Or 1 equals 1. Alright, I'm tired. I'll do more tomorrow. I'm gonna get up early. That's pretty interesting though, I ain't gonna lie. I wanna do more, but I'm just too tired right now. Way too tired. So I'll finish that tomorrow. Check some shit out. Yep. Oh, I'm tired. Alright, guys. I'll see y'all tomorrow. I'll finish that tomorrow. I'm just tired. I gotta get up early.